It's Flashcard Fridays at Math, Science, History, and I'm your host, Gabrielle Birchak. And today, we are talking about resilience, the stubborn, steady kind that keeps you walking when the world shouts, "Turn back!" In case you missed this Tuesday's episode, it was about Dan Shechtman and his discovery of quasicrystals. This discovery rewrote crystallography, but it was not immediately embraced, and so he faced adversity. Despite that, he went on to win a Nobel Prize for his discovery, despite the overt rejection that he faced early on. His story is one of adversity. His story also reminds me of another scientist that endured adversity and challenges along the way. His name is Ahmed Zewail. But first, a word from my advertisers. What if you could watch molecules move? Not just imagine them or model them, but actually see the instant chemical bond breaks or forms or rearranges. For centuries, chemistry has been the science of transformations, but those transformations seemed impossibly fast. Too fast for the human eye or even for the most sensitive instruments. That is, until a scientist named Ahmed Zewail found a way to do it. He captured chemical reactions in real time using flashes of light measured in quadrillionths of a second. His work didn't just open a new window into chemistry, it opened a whole new era. But Zewail's story isn't just about lasers and molecules, it's also about resilience. He was born in a small town in Egypt, faced limited resources, crossed continents, and pushed through skepticism until the world recognized him with a Nobel Prize. Let's take a closer look at Ahmed Zewail, the father of femtochemistry and the lessons of resilience his life still teaches us. Ahmed Zewail was born in 1946 in Damanhur, Egypt, and grew up in the nearby town of Dusuk. His father worked as a mechanic and later as a civil servant. His family valued education, but life in provincial Egypt was far from glamorous. Egypt in the 1950s and the 1960s was undergoing massive change. Gamal Abdel Nasser's government pushed modernization, but political unrest and economic challenges were part of daily life. Access to cutting-edge science was something young Egyptians could only dream about. But Ahmed was captivated by chemistry. He studied it at Alexandria University, where he earned both his bachelor's and master's degrees. Still, he knew if he wanted to be at the forefront of discovery, he would have to leave Egypt. This was no easy step. Traveling abroad required scholarships and sacrifice. Zewail arrived in the United States in the 1960s with modest English and little money. The cultural transition was intense. Ahmed later recalled how overwhelming it felt to be thousands of miles away from his family, carrying not only his dreams, but the weight of representing Egypt in a world where Arab scientists were often dismissed. Still, he pressed forward. He won a PhD position at the University of Pennsylvania, where he studied with Robin Hochstrasser, a pioneer in laser spectroscopy. It was there that Ahmed began to imagine how ultra-fast lasers might capture the unseeable. So, chemistry happens fast, incredibly fast. If you've ever studied it, you would know this. Chemical bonds form and break in femtoseconds. A femtosecond is 1/4 of a second, or 10 to the negative 15 seconds. So I'm going to give you some context here. 1 femtosecond compared to 1 second is like 1 second compared to 32 million years. Kind of mind-blowing, isn't it? So, before Ahmed, no one thought it was possible to study events on this timescale directly. Chemists could measure before and after, but the in-between was invisible. Ahmed changed that. In the late 1980s, working at the California Institute of Technology, Caltech, he developed a method using ultra-fast laser pulses to capture snapshots of molecules in the midst of a reaction. It's freaking mind-blowing. The result was nothing short of revolutionary. For the first time, scientists could see a chemical reaction unfold in real time. They could watch the energy shift, the bonds vibrate, and the molecules dance. This was femtochemistry, chemistry on the femtosecond timescale, and the implications were huge. It deepened our understanding of fundamental processes like photosynthesis, combustion, and molecular vibrations. It opened the door to advances in medicine, nanotechnology, and material science. It gave humanity a new way of seeing nature at its most basic level. In 1999, Ahmed Zewail was awarded the Nobel Prize in Chemistry for this breakthrough. He became not only the first Egyptian Nobel laureate in science, but also the first Arab scientist to win the Nobel in Chemistry. But Ahmed's story isn't just about success. It's also about what he overcame. First, he was exposed to skepticism. When he first proposed femtochemistry, some doubted it was even possible to capture chemical events so quickly. His persistence in refining techniques and presenting results convinced the skeptics. He faced immigrant adversity. As a young Egyptian scientist in America, he often felt underestimated. He had to prove himself in spaces where Western scientists dominated. He faced political resistance. After his Nobel Prize, Ahmed wanted to help reform science education in Egypt. He spearheaded the creation of Zewail City of Science and Technology in Cairo. But bureaucracy, political infighting, and the turbulence of the Arab Spring slowed its progress. And then finally, he faced the adversity of personal loss. Ahmed lost his first wife to illness and later battled cancer himself, which he publicly acknowledged late in life. Even as his health declined, he continued to teach and mentor. And through all of this, Ahmed never lost sight of his mission to expand the frontiers of science and to inspire young people in Egypt and beyond to believe that they too could change the world. Ahmed Zewail passed away in 2016, but his legacy lives on in multiple ways. Scientifically, femtochemistry transformed chemistry forever. Today, ultrafast spectroscopy is a standard tool in laboratories worldwide. Institutionally, Zewail City of Science and Technology continues to train scientists and engineers in Egypt. Personally, he inspired a generation of Arab and Muslim students to see themselves as part of the global scientific community. He was fond of saying, "In the end, science is part of society, and society has to value science." His story is proof that resilience, the willingness to persist, adapt, and dream can turn the impossible into a discovery. So, what can we learn from Ahmed Zewail? Well, first, resilience overcomes limits. Growing up with modest resources in Egypt didn't stop him from capturing molecules in motion. Resilience continues to overcome any limits you may think you may have. Second, persistence beats skepticism. And that is an overstatement. When you persist and just ignore the skeptic voices in your head, you can do this. When others doubted femtochemistry, Zewail refined and proved his methods until the data was undeniable. And third, science needs vision. He didn't stop with a Nobel Prize. He worked to build institutions so that others could follow in his path. So, resilience. It requires resilience from overcoming limits, persistence to beat skepticism, and a vision. So wherever you are in your life today, whatever challenges you are facing, remember, when you are persistent, when you just keep going, and when you have a vision, you can get to where you want to be. I'm Gabrielle Birchak, and this has been Flashcard Fridays with Math, Science, History. Until next time, remember, resilience in science, or resilience in general, isn't about experiments or retrying things. It's about refusing to give up on discovery. It's about refusing to give up on your endeavors. And it's about refusing to give up on yourself. And until next time, carpe diem.